Welcome to Unit 4, Lesson 3, the derivative of sine x and cosine x. From our previous lesson, we know that the graph of sine x looks like this. It oscillates, that means it goes up and down again, and it starts at the middle, 0. So what does the derivative of f of x look like? Now let's go to decimals. Let's graph f of x equals sine x. The graph looks like this. Let's look at some key points. Let's think about what the graph of the derivative will look like. At 0, 0, it's going up. The graph is going up, so clearly the graph is positive. F prime of x is positive at x equals 0. But what is the slope? To estimate better, I'm going to change the coordinates. So let's go 1, 2, 3, 4 for x and 1, 2, 3, 4 for y. Let's draw our line, our tangent line. Our line tangent to x equals 0. Let's see what it looks like. Something like this works really well. There you go. This line has the same slope, roughly the same slope, as sine of x at x equals 0. What is the slope of this line? Well, we are going... The rise is 1, 2, 3, 4. The run is 1, 2, 3, 4. So the slope is 1, 4 over 4. In other words, the slope of sine of x at x equals 0 has to equal 1. Well, we want to graph f prime of x, so let's graph it right here. At x equals 0, f prime of x is equal to 1. Next, at x equals 90 degrees, or pi over 2, which is right here, what is the slope of this line? Well, when the graph is at its maximum, the line is not going up anymore, it's not going down anymore. The slope has to be 0 right here. So therefore, we see that f prime of x must be equal to 0 here. Similarly, at this point, at x equals pi, we can see that the slope is roughly negative 1 right there. In fact, it's exactly negative 1. So the slope at x equals pi, f prime of x is negative 1. And here, the slope is 0 again. And if we go, so we see the graph looks like this. Here, at x equals negative 90 degrees, same thing. F prime of x is 0. And then the slope is negative 1 here, and so forth. So in fact, the graph of f prime of x should look like this. Yeah. It should look like this. Okay. So if this graph is sine of x, f of x equals sine of x, then f prime of x should look like this. Does this graph, the graph of f prime of x, remind you of anything? It also oscillates. It goes up and down, and it starts at 1 when x equals 0. From the last lesson, we saw that this is actually just, first of all, let's confirm. Yep, this is in fact f prime of x. We said that this is f prime of x. What is it? Well, f prime of x is actually just cosine of x. See? Same thing. F prime of x and g of x are the same. So what did we learn? We learned that if f of x is sine of x, the derivative of sine of x is just cosine of x. Okay. We can repeat the same process. This time, let's use g of x as cosine of x. Let's see what the derivative of cosine of x looks like. You might guess, hey, the derivative of cosine of x might be sine x, because its derivative of sine x is cosine x. Let's see if we're right. So, at x equals 0, cosine x is at its maximum, so it's not going up or down anymore. So the slope is 0 right here. At x equals 90 degrees, the slope is negative 1. At x equals pi, the slope is 0 again. At x equals 270 degrees, the slope is 1. And so forth. So let's draw a graph of the derivative of cosine x. So let's say if we're right, is this sine of x? Well, first of all, let's check. G prime of x, in fact, looks like this. Okay. Is that sine of x? And the answer is no, it's not sine of x. The derivative of cosine of x is not quite sine of x. Instead, look, they're just inverses of each other. In fact, the derivative of cosine of x is just the negative of sine of x, and now they are the same. So what did we learn? We learned that if f of x is cosine of x, the derivative, of course we can also write it as df over dx, it's not sine of x, but negative sine of x. Okay? So let's summarize what we learned. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine x. Let's use those to try some examples. Example 1. If f of x is 3 cosine x plus sine x, what is the derivative? We know from the last unit that we can just differentiate, find the derivative of each term, and then add them up, because this is the derivative of sums is the sum of the derivatives. The derivative of cosine of x is negative sine x, but this is 3 cosine x, so the derivative is negative 3 sine x. That's the first term. Second term, we have sine x, so the derivative is cosine x. In other words, if f of x is 3 cosine x plus sine x, then f prime of x is negative 3 sine x plus cosine x. One more example, f of x is x squared times x squared times sine x minus 1. We have two terms here. We can apply the product rule. So f of x is x squared, and then the derivative of the second term, the derivative of sine x is cosine x. The derivative of negative 1 is 0. So the first term is x squared times cosine x, plus the derivative of the first term, which is 2x, times the second term. In other words, if f of x is x squared times sine x minus 1, then f prime of x will be x squared times cosine x plus 2x times sine x minus 1. Okay? So that's it for this video.